Good evening, everybody, and welcome to our video tonight, where we're going to be talking about parallel lines and transversals. So first, we're going to start off with some vocabulary. I'm going to show you a couple symbols, and then we'll explain transversals and show you a diagram there. And we'll do some practice problems with these concepts tomorrow in class. So first off, let's start with some vocab. And so I want you to write down all of these vocab terms and their definitions, and then also draw in the diagrams here as well. So the first thing we're going to talk about are parallel lines. And parallel lines are coplanar lines that do not intersect. And with this, you also are going to want to write off to the side that these are coplanar lines that do not intersect. You might also say that they never intersect. That's another thing to think of. So not just that when you draw the picture, they don't cross each other, but that if you were to extend these lines forever, they would never intersect. So that's the concept. Not just that they don't in the picture, but that they never will. Okay? And it's important to note that they're coplanar, right? So that when we think of parallel, we think of like two streets that are right next to each other that will never cross, right? Because the next concept, the skew lines, are going to be non-coplanar. Okay, so parallel lines are coplanar lines that do not intersect. When we're talking about lines, remember we can name them a couple of ways. So I could use the lowercase script letters. So I could call this line L and this line M. Another way that I could name these two lines is using a couple of points on the line. So I could call this point A and point B, and call this point C and point D. And so I could name these lines either way. Symbolically, to say that these two lines are parallel, I would say that line L is parallel to line M, and the symbol for parallel is two straight bars. The way I always think of it is it's like the L's in the word parallel, right? So that's one way to write this symbol, or to say these lines are parallel. Another way would be to use our symbols for lines and saying line AB is parallel to line CD, right? So those are the two ways that I could write this. Another thing that you might see to indicate that two lines are parallel is an actual mark on the lines, and the mark is like a filled in or a solid triangle on each line that is parallel to each other, right? So just like we have little hash marks to indicate segments are congruent, or we have little arcs to show that two angles were congruent, we have two arrows to show that two lines are parallel. Okay, so those are the symbols that we'll use. And remember, you can name a line either with a lowercase script letter or the 2 points that are on the line. Okay, so those are two ways you'll see this written. Now, like I mentioned, it's important to note that in the definition of parallel lines, we have the word coplanar, because we can also have another set of lines that do not intersect, and those are what are called skew lines. Skew lines are non-coplanar. So I drew a box here to kind of help visualize that. So two lines that are skew lines in this picture would be like the bottom edge of this box. So like this line right here, that would be one line, and a skew line to it would be the back edge of the box that goes up and down, right? So this is on the front bottom going left to right, and then this is the back edge, so it's a little bit pushed back from this line. So these lines would never intersect. And they're also not on the same plane, right? So this is up on this face of the box, and then this is on the back face of the box. So they never intersect, so they're skew lines, but they're not on the same plane. And we don't really have any symbols that we would use for that. It's just important to note that that's another way that two lines will not intersect. And then lastly, we have planes that do not intersect. We can also call them parallel as well. So the top and bottom of a box, right? So I kind of took the same image here and just erased the sides. And so the top and the bottom of the box are parallel planes. They never cross. So even though they extend infinitely off at that level, they never would intersect or move up to intersect this one. So they're parallel. Okay, so we've talked about parallel lines. We've talked about lines that don't intersect. What about lines that do intersect? That's another important concept. So when lines intersect, they form a bunch of different angles, right? So anytime I have two lines that intersect, there's 4 angles right there. Now when I start drawing multiple lines together, then I have a bunch of different angles, okay? And the relationships between those angles are going to be very important, and we're going to have all kinds of theorems about those relationships, and so that's what we're going to spend some time with in the rest of this chapter. But first off, let's talk about an important line, another definition of something that's called a transversal. So a transversal is a line that intersects two or more lines in the same plane. So if I have these three lines here, we'll call this script letter T, we'll call this M, and we'll call this N. In this case, T is the transversal. So it's the line that intersects two or more lines. So T crosses both M and N, right? So that's, T gets a special name. It's called the transversal because it intersects more than one line as it goes through. Now, M and N would eventually intersect, right? Because if I extended this line off this way and this line off this way, they would cross each other over here. So even though they don't cross each other in the picture, that doesn't mean they're parallel. They would intersect over here. And just because they only intersect each other, technically M would then be a transversal for T and N. But in this picture here, we're just identifying T as the transversal because it's the one that intersects two or more lines in the same plane. Okay, so when we have this, when we see a transversal, we want to identify all the angles that are made by the intersecting lines, and we have special names and relationships for them. So in this picture over here, I have another transversal. Let's just call this one L, and then we'll call this line A, and we'll call this line B. Okay? So when I have this transversal L cutting across line A and B, I see a bunch of different angles that are formed. And so I'm going to number all those angles. We'll call that angle 1, that's angle 2, angle 3, and angle 4. Okay, so 4 angles are cut right there. Then over here I have angle 5, angle 6, angle 7, and angle 8. And so I have 8 total angles that are made up whenever I cut a transversal through 2 lines. Now if I have more lines on here, every time I have 2 intersecting lines, basically I'm making 4 more angles. Okay, so now I have some special relationships, and these angles can be classified in a few different ways. The first type are what are called exterior angles. And so these are angles that are on the exterior, and it's kind of hard to describe that. One way that I think of it is like if there's an inside box here between A and B. So there's this area between the 2 lines that are cut by the transversal. And then there's this area outside that's kind of not bounded by anything, right? It goes off, there's no lines cutting it. But here, these are kind of like bounded by these 2. So exterior are angles that are on the outside. So in this case, angle 1, angle 2, and angle 7 and angle 8 are the angles that are exterior angles, right? They're all the ones that are on this outside. Now the angles that are all inside between the 2 lines that are cut by the transversal are what are called interior angles. So exterior, outside, interior, inside. So these are terms that you can write off to the side, outside or inside angles to kind of help you remember these. So I have 1, 2, 7, and 8 are exterior. So that leaves angle 3, angle 4, angle 5, and angle 6 as my interior angles. Now we have some other relationships. So those are the exterior, that's all the interior, and now there's kind of different relationships among them. So to call something a consecutive interior angle, I learned this as being called same side. So consecutive, or you could call this same side interior angles. That's another option there. So same side interior angles are, or consecutive interior angles, are the interior angles that are on the same side of the transversal. So in this case, the same side interior angles are angle 3 and angle 6. Those go together because they're on the same side. And then there's another pair of them, angle 4 and angle 5. Right? So angle 4 and angle 5 go together. So there's 2 sets, right? There's 2 sets of consecutive interior angles. Now, alternate exterior angles. So another word that you could use for that would be opposite, right? That was the word that I used when I learned about these. So opposite exterior angles. So opposite means they're on alternate or opposite sides. So the exterior angles that are opposite. So in this case, I have, and so when I say opposite, I mean not just across from each other like 1 and 2 are, because those are across from each other and they're exterior angles. But opposite is completely opposite. So on the opposite end and across, right? So they're alternate exterior. So they're across from each other in both ways. So on the other side and over on the other side of the transversal as well. So they're on the other side of the other line and on the other side of the transversal. So my two pairs are angle 1 and angle 7, and then angle 2 and angle 8, right? So 1 and 7, they're completely opposite. So 1 is on this side of A, 7 is on this side of B, and then it's also on the opposite side of the transversal. Then we have alternate interior angles, and so for those two, we're going to have another couple of pairs. They're opposite again, so 3 and 5 are going to be our first pair, angle 3 and angle 5, because they are on the opposite sides of the transversal. And then angle 4 and angle 6 are the other interior angles that are opposite from each other, right? So we wouldn't call 3 and 4 opposite because we'd call them more like adjacent, right? So if we had adjacent interior angles, I could call those 3 and 4 adjacent interior angles, but in alternate, we're going to call it like 4 and 6 and 3 and 5, okay? And the last set that we're going to talk about are corresponding angles. And when you think of corresponding angles, you're kind of thinking of, so we said when a transversal cuts over a line, there's 4 angles that are made, right? In each one of these. So when you're thinking about corresponding angles, you want to pick the angle that's made by line L and A that corresponds to the same angle that's cut by L and B. So in this case, 1 and 5 are corresponding angles. So you're thinking which one of this set up here, this set of 4, corresponds to which set of 4 over here. And you're thinking of it like in terms of like clockwise around this intersection. So here we would have angles, let's see, is there a color I haven't used yet down here? That's purple, let's use black. All right, so angle 1 and angle 5 are one set of corresponding angles, right? Because those match up. That means angle 2 and angle 6 is the other pair. Then I have angle 3 and angle 7 as corresponding. I'm sorry, that's angle 3 and angle 3. I should write angle 3 and angle 7 as corresponding. And then the last pair are angle 4 and angle 8. All right, so we're going to do some more practice problems in class with these tomorrow, where you're going to see transversals and some different lines that are intersected, and you'll have to identify which ones are consecutive interior or alternate exterior and that sort of thing. So review this, bring these notes with you to class tomorrow, and we'll do some practice problems then. Have a great night.